Hi chemists, how are you going? Just want to talk you through an example back titration question. So we'll read through this one. Eggshells contain calcium carbonate. The following procedure was used to determine the percentage by mass of calcium carbonate in 1.13 grams of eggshell. So the first step, the eggshell was crushed and added to 100 milliliters of 0.300 moles per liter hydrochloric acid solution. The excess HCl remained after the reaction completed, ended up being titrated in the second step. So this is the reaction. So essentially the remaining HCl is going to be titrated in step 2. So 20 ml samples of excess HCl were titrated with 0.10 moles per liter sodium carbonate solution. So the sodium carbonate is our known solution, that's our analyte, and we're using that to determine the amount or number of moles of HCl, and then we work backwards to figure out the amount of HCl that reacted with the calcium carbonate. So, reacting with the calcium carbonate which is in the eggshell. So the first step is to calculate the initial number of moles of HCl present before the reaction in step 1. So the number of moles of HCl, what we're going to be looking at is this information up here. So HCl, 100 mils and 0.3 moles per liter. So before the reaction in step 1, I know that I'm looking up here, and the first information I get of HCl is this information here. So I can calculate my number of moles of HCl by doing concentration times volume. So that's going to be 0.300 multiplied by the volume. Remember to convert your volume to liters, so divide by 1000. So that's going to be 0.1. It would be 0.1000 theoretically. So that's going to be 0.0300 mole. Now this answer is to 4 sig figs and this is to 3 sig figs. So I'm going to round off to the least precise measurement, which is 3 sig figs. Okay, so part 2, the equation for the titration reaction in step 2 is shown below. So this was the initial reaction with the eggshell, and this one is now the titration reaction. In one titration, 8.35 milliliters of sodium carbonate was needed to neutralize the HCl in one 20 ml sample. So we calculate the number of moles of Na2CO3 needed to neutralize the HCl in step 2. Now you can see that these questions are very wordy. So what we'll start doing is underlining the next information to do with the sodium carbonate. Okay, so we have a volume of sodium carbonate that's required to neutralize, and we want to calculate the number of moles. So I'd be looking for a concentration of sodium carbonate. And I can see that up here in the step 2. So we have 0.10 mole per liter sodium carbonate. So that's the quantity that I'm using here. So the number of moles of Na2CO3, same thing as before, C times V, so that's 0.10 multiplied by 8.35 mil, that's going to be 0.00835. Converting to liters. So that ends up being 0.000835 mole. Or if you convert that to scientific notation, if you make the decimal place, and I'll change colors here, if you make the decimal place jump 1, 2, 3, 4 spots to the right, that means you're going to end up getting 8.35 times 10 to the power of -4 mole. Okay, so part 2, hence state the number of moles of HCl in the 20 ml sample titrated in step 2. So we want to find the number of moles of HCl. So even though we're finding out HCl, this number of moles of HCl is what we use initially. And over here, we are using HCl that is in excess. So essentially that's present after the initial reaction with the eggshell. So even though I'm working out the number of moles of HCl, I'm just going to do a different color to indicate the number of moles of HCl that is in excess. So I'll use green for that, just to help me differentiate the two. So the number of moles of HCl, and we can write excess if we like, I might just leave it as a different color though, is going to equal the number of moles of Na2CO3. So this is mole ratio stuff, because these are the two substances that have reacted with each other. Okay, so times by the mole ratio, which is unknown over known. So that's going to equal this answer here. Okay, so 8.35 times 10 to the negative 4 multiplied by the mole ratio. Now the unknown is the HCl, so the ratio is 2, and the known is the sodium carbonate, and that's 1. So we're multiplying by 2 over 1, so we're just multiplying it by 2. And that is going to equal 0.0017 mole. You could also have that in scientific notation, but that's fine. So part 3, I've run out of room a little bit here, so I might just take this and get rid of that, move that up, give myself a bit more space. So the next question, hence calculate the total number of moles of excess HCl that remained after the reaction with the eggshell in step 1. Now, this might be a little bit confusing because what is it that we're exactly looking up? So the key part here is recognizing that in the previous question, the HCl that's being titrated against is 20 mil samples, okay? 20 mil samples. But the initial quantity or the initial volume of hydrochloric acid that was used was 100 milliliters. So the number of moles that was present in the 20 mil sample with the titration is here, but the number of moles of the excess HCl is 100. So essentially, if there's 0.0017 mole in 20 mil, how many moles will there be in 100 mils? It would be 5 times the amount. You can hear my dog in the background, sorry about that. So it's going to be 0.0017 multiplied by 5. And that's going to be 8.4 times 10 to the negative 3 mole of excess HCl in the 100 mil. Okay, awesome. So the next part, calculate the number of moles of HCl that reacted with the eggshell in step 1. Okay, so this quantity here was the amount that remained after the reaction with the eggshell in step 1. And we know the number of moles of initial HCl before we reacted with the eggshell. So this is the back titration part. So this is that extra step. So all you need to do is say the number of moles of HCl that reacted is equal to the number of moles of HCl initial. So I've done that one in orange, so that's the initial. Subtract the number of moles of HCl in excess. Okay, so that's what we started with. That's what was left over. So if you subtract the difference between the two, that's what reacted with the eggshell. Okay, so that's that extra step. So we'll grab this, take away this, And that gives us, back to my blue, and that gives us 0.022 mole. Okay, so from there, we calculate the mass of calcium carbonate in the 1.13 grams of eggshell. So to get the mass of calcium carbonate, we first of all need the number of moles of calcium carbonate. Now you might think mass, I need to get number of moles times by molar mass or something like that, but that's not what we're doing. We're doing another mole ratio, okay? So the first equation, these are the reactants, okay? And now that we have the number of moles of HCl that reacted, we can calculate the number of moles of the calcium carbonate by using that mole ratio. Okay, so the unknown is this, and the known is this. So essentially, this equation is what we're using to get that mole ratio. So let me use, I'm running out of colors here, but that's okay. So the number of moles of CaCO3 is going to be the number of moles of HCl that's reacted multiplied by the mole ratio, so unknown over known. So that's going to be 0.022 multiplied by the unknown is 1 and the known is 2. So it's going to be half of it, so 0.011 mole. Now we need the mass of calcium carbonate. So scroll down a bit here. I might just delete this because I'm running out of room. Oops. Okay. So the mass of calcium carbonate, and my writing's getting super messy here, is the number of moles times by the molar mass. Now I'm just going to cheat here and Google the molar mass of calcium carbonate. So let's get that over here. Molar mass of calcium carbonate, 100.09. So we'll just roll with that. But you need to know how to calculate molar mass. So we have 0.011 times by 100.09 grams per mole. And that will give us 1.1 grams of CaCO3. Okay. So the last part is super easy. Calculate the percentage mass of calcium carbonate in eggshell. That's just like any percentage. Okay. So it's essentially what you're looking at. So the calcium carbonate accounts for 1.1 gram of mass in the eggshell. So 1.1 grams of the calcium carbonate divided by the total mass. So the total mass is 1.13 grams of eggshell. And we multiply that by 100. And that gives us 96%. And that's weight of calcium carbonate per weight of eggshell. Okay, so 96% of the eggshell is made up of calcium carbonate. Thanks for watching, guys. Hopefully that helped. There's a bunch more practice questions. So hopefully after a bit of a breakdown with that, you've gotten a bit of an idea just how these questions look. The fact that you want to try and color code, because there's lots of writing with this stuff, so you want to try and have it color coded to help you to figure out which numbers are relevant for which part of the problem. But it is stepped out relatively, I won't say straightforward, but it's stepped out relatively well, these questions. So give them a go, and good luck.